Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 9 in the cross-site request forgery module titled SameSite Lax Bypass via Method Override. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on cross-site request forgery labs and go down to lab number 9 titled SameSite Lax Bypass via Method Override. Alright, let's get started. This lab's change email function is vulnerable to CSRF. To solve the lab, perform a CSRF attack that changes the victim's email address. You should use the provided exploit server to host your attack. You can log into your own account using the following credentials, and we're giving credentials of a regular user account. We also have a note over here saying the default same site restrictions differ between browsers. As the victim uses Chrome, we recommend also using Chrome or Burp's built-in Chromium browser to test your exploit. Alright, so the target goal over here is to exploit the CSRF vulnerability to change the victim's email address. Let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. The first thing we're going to do is log into the account that we were given. So the password was Peter, hit login, and then you could see over here we've got a change email functionality, which is the functionality that we want to perform our CSRF attack on. So let's just change it to see how this functionality works. So let's say update email and look at the post request right over here. So it's a post request to the /myaccount/change email endpoint. And if you look down right over here, you could see that it only takes one parameter, which is the email address. Right away, the fact that it doesn't take in a CSRF token tells me that this is vulnerable to cross-site request forgery. But we do have to take one thing into consideration, which is the same site attribute. If it's set to strict, that means that it won't pass the session cookie in cross-domain requests, and so we might not be able to exploit it unless we find some kind of functionality or vulnerability in the application that allows us to bypass the same site configuration. So the first thing that we need to do is really determine what configuration is set for the same site attribute. And the way to do that is we need to go back to our login request and look at the session cookie when it's being set. So over here, you could see there's the secure attribute, which means that it can only be passed over HTTPS. And then you've got the HTTP only attribute, which means that JavaScript can't access this cookie. This prevents cross-site scripting vulnerabilities from accessing the session cookie and then compromising the user account. But you could see over here that there is no same site attribute. And so what will happen is that when the application loads in the browser will use its default setting, which is Lax for the Chrome browser. And we saw over here that the victim user is using the Chrome browser, and so same site will be set to Lax. Now this means two things. One, for a CSRF attack to work, it has to be done using a get method because the Lax configuration does not allow the session cookie to be passed over a post method. So we have to somehow get this functionality over here to work over a get method. And then the second thing is that the request has to be from a top level navigation by the user, such as a user visiting a site and then clicking on a link that generates that request, or even if it's a script in that site that performs that request, it'll still work, but it can't be something like an iframe. So really, what's stopping us over here is the fact that the email change functionality is in a post request. So if we go back to it, it was this one right over here. Let's send this to repeater. Go to repeater over here, right click, and then say change request method and see if this works. Hit send. It does not. So you could see over here it says method not allowed. I'm going to try one more thing. I'm going to add the parameters. So end _ method is equal to, and I'll say post. So this parameter is supported by some frameworks, and essentially what it does is it allows you to override the method. So let's hit send right over here and see if that worked. Interesting, it did work. So if we follow the redirection over here, you get redirected to the My Account page. Let's change this to, so let's go back and change this to test1 at test.ca to confirm that it is really properly working. Hit send, follow redirection, and reload this over here. And you could see it did change my email address. So we essentially have everything that we need to bypass the SameSite Lax configuration because we were able to perform the request over a GET method. So the next step is to write our script in the exploit server. Send the link of the exploit server to the victim user, and then when the victim user loads a page, it'll automatically perform that request and change the victim user's email. So to do that, I'm just going to write my script right over here and then copy it into the exploit server. So we'll start off with the script tag. And then this is a really simple script. We'll just say document.location is equal to the link that is responsible for changing the email address. So if we go back right over here, let's copy this, which is the URL to the application. So that would be HTTPS. And let's click on view and word wrap so that everything appears in one page. And if we go back over here, this is the rest of the URL. So let's copy it, put it in here. So far, so good. Now let's change the email address to, let's say, test2 at test.ca. Let's copy this entire thing, paste it in here. And then we're just going to view the exploit, which means that it'll run within our browser. So it should change our email address to test2 at test.ca. If it doesn't, that means something's wrong with our exploit. So click on view exploit. And here we go. It changed our email address to test2 at test.ca. So the next step over here is to just change up the email address again because they do have to be unique and deliver the exploit to the victim user. And here we go. So you could see that congratulations, you solved the lab message. All right, so we successfully completed the exercise by exploiting the cross-site request forgery vulnerability. In the next lab, we'll look at another case of a CSRF vulnerability.